Good morning, everybody. Hopefully you're doing well out there today. Give me a green check mark and we'll get going here in a second. We're just going to keep going through the Science 10 practice exam like we were going through last day. And I don't foresee this taking a long time today, so I know we have a double block booked out, but probably we'll finish a little bit earlier. So what I want to do today is I want to go through any questions you guys might have to start, and then I'm going to continue finishing off that exam, so we'll polish it off the second half of the exam today. And then I don't have anything else planned. I mean, there's no new material to teach you, and there wouldn't be any point in me just blathering on about nothing. So if you guys have specific questions about anything related to anything, if it's like alpha, beta, gamma you don't understand, or if there's something in one of the learning guides, or a concept that you maybe didn't pick up along the way and you want me to go through that, I'd be happy to do that. But if nobody has any questions really specific to anything, then I'll finish off this exam and then we'll just call her a day there. So I guess I'll just jump right into the exam. We left off last day on question 47. So this was the beginning of the radioactivity unit. Did anybody have any specific questions before we begin? And if you don't, I'll just continue on with this stuff. Basically go through the last half of the exam. Next class will be our last block. And I don't have any new material, obviously, but I'll come up with a little bit of a review just to kind of jog your guys' memories, and just hopefully you guys can have everything in by Friday, and then it won't really matter, you know. We'll be ready to rumble for the test. There is an open house on Wednesday the following week, so a week from today, from 1 to 3. If you want to come in, you can do some exam review. I have some old exams if you want to look at those. I can talk about anything that you want to look at. So a week from today, 1 to 3, it's Wednesday, and I'd be happy to go through anything that you might have come up with in terms of questions. So yeah, for sure we can do that. Abby, do you know when your test is, Taylor? I don't, but I'll check into that. I think you might have the full week, Taylor, because you are going to write yours online, I assume, whatever school you go to. So I'll find out that information for you today, and we'll get some exact dates and times for you, and we'll arrange that for you. So I'll send you an email in a little bit. So Abby will do that in a little bit here. And again, when I'm going through this, if you guys run into any problems, let me know, and I can, slow down and take a look at the questions more specifically. So what information can be used to identify an isotope? So remember, isotope is something with a different number of neutrons, same element. Protons defines an element. Differing amount of neutrons changes the isotope. So that was the element symbol and mass number. If you know those two pieces of information, you can figure it out. The daughter isotope of nickel 60. So again, this isn't something you need to memorize. You just go to the back of your data booklet and it says parent, daughter. So you find where it says find the parent nickel 60, and then the daughter is just listed there. Pretty straightforward. One of these free marks, I've referred to them as gifts, and I will continue to refer to them as gifts. This one isn't a gift, actually. This is nickel 60. Just looking at my notes here. And that is 28. So it's an alpha decay question. And it doesn't tell you... thanks, Abby. It doesn't tell you what the product is. So it's a fancy way of asking an alpha decay question. So you do the math. 28 is 2 plus what? Well, 26 plus 2 is 28, and then 60 is 4, so 56 plus 4 is 60. I look up element 26 on the periodic table, and that is iron. So this is iron 56, which is letter A. So there you go. Number 49 is a half-life question. Remember to draw in the little table, half-life, time, and amount. And every time you do this, it's always the same process for every half-life question. I'm pretty confident that you won't get anything with like partial half-lives. We had a few in the notes in the learning guide where you had to use that formula. I've never seen one like that on a provincial, so I wouldn't stress out about that too much. You should always be able to draw one of these little charts to figure it out. For a question like this, will there always tell us what type of decay? Yep, there's no way that they could ask you a question like 48 without asking you or indicating some type of decay, because different elements will decay at different, types of particles. So there's no way you could memorize all the elements and how they all decay. So they'd always tell you if it was alpha, beta, or gamma. You'd have some indication. I'll just go through this because sometimes these half-life questions are a little bit tricky. So it tells you that the half-life is 3 minutes, and it says you're starting with 160 grams. So if I go through one half-life, that's 3 minutes, I'm down to 80. 2 half-lives is 6 minutes, 40, 3 half-lives, 9 minutes, 20, 4 half-life is 12 minutes, and 10. So when I'm down to 10 grams, that's 4 half-lives or 12 minutes. So these charts will always figure it out. And you notice that the question started with a really nice number, like 160. So each time you divided by 2 was a nice integer value for the mass, which is the way they almost always will work out. So there you go. What of the following isotopes can undergo nuclear fusion to produce helium-3? This is a bit of a tricky question. If we're undergoing fusion, that means we have 2 things combining together to give us one thing and possibly like a neutron or something like that. So helium-4 is already bigger than helium-3. So if I'm joining 2 things together, they have to be smaller than what I'm trying to produce. So if I'm trying to produce helium-3, which has a mass of 2, then the things that I'm combining together have to be smaller than that. So the only one that's smaller to begin with is hydrogen. All the rest are larger already. So helium-4 is too big, carbon-14 is too big, uranium-235 is way too big. So a tricky question, but if you had maybe a bit of common sense in terms of fusing things together, if you understood what fusion was, you should be all right. If this said fission, then you would probably be looking at something large like uranium. Will those questions always have a time in it? Taylor, not necessarily. You could say there could be a question such as they've given you like the number of half-lives, and they've given you the starting mass and the ending mass, and then they could ask you to find the time that's occurred. So basically, I've got these 3 columns here, half-life, time, and the amount. You're always going to get 2 of the 3. They're going to have to give you 2 of the 3 things in order to figure out the question. So they could give you half-life and amount, and then ask you to find time, or they could give you the other ones and ask you to find, maybe they could give you this one and ask you to find the half-life. So you don't always end up with time. Sometimes they can ask you to find time. It just kind of depends on how they design the question. All right. Did I skip it? No. 51. One method to produce plutonium-238, nucleus uranium-238, deuterium, blah, blah, blah. What combinations of beta particles and neutrons are produced? Again, it's just a matter of putting them in to see which one works. In terms of the math, one thing when you guys did question like this in the learning guide, I wouldn't say a lot of people made the mistake, but a few people made the mistake. If we just, for a second, look at a simple beta decay type question. Let's say I have uranium and it's undergoing beta decay, and I want to know what's produced. A lot of times, when you guys were doing this, you were making mistakes on the math. You were saying, okay, this should be 91, and then 238. But the problem with 91 is this. If I think of this as a math equation, I have 92 is equal to negative 1 plus 91. Well, if I go 91 minus 1, I end up with 90. Does 92 equal 90? No, it doesn't. So that's not right. Same goes for this question. When you're doing beta decay, it's kind of a little bit backwards. You want to pick a number that's actually one larger. So if I picked 93, I would have 92 is equal to negative 1 plus 93. And that's the way it works out, because 93 minus 1 is 92, which is equal to 92. So be careful with beta decay. The math works, but you need to remember it's a negative one, not a positive one, because that has an effect on how it works out. That has nothing to do with this question. Well, I guess it kind of does, but in this particular question, you just need to fill in the two blanks here. And the way it works out is this combo right here. So 1 beta particle and 2 neutrons. You could just put in all the answers and see if the math works, and that's the only one that happens to work. So that's 51. 52. Notice we're into physical science, so we're now kind of the physics type questions. What are the following quantities is displacement? This is trying to figure out if you know the difference between a vector and a scalar. Of course, displacement is a vector, so you need to have a magnitude and a direction. So the first two don't have a direction, so they're automatically wrong. This one has the east and meters, which is what we're looking for. Displacement is the measure of distance. Number 53, please promise me that when you guys see a graph on your test, you'll look at the axes and figure out if it's position time or velocity time graph. In this particular example, we have a position time, and it asks when the velocity is negative. So hopefully remember the slope of a position time graph is velocity. And the only time we have a negative slope is in this little section here, which is B. '54, another graph type question. Again, we're given we're given position and time, not velocity and time, so make sure you've identified that. Calculate the velocity of the ball. I see that it's a position time graph, so nowhere on the graph is a velocity given. When I say have a position time graph, I need to find the slope. I can pick 2 points on my line. Doesn't really matter what 2 points you pick. I'll pick those two. And then rise over run. You can think of it as ordered pairs, kind of like we did in math. So what do we have here? We have 0, 2, and 25, 10. We're going to go 10 minus 2, 25 minus 0. And we should end up with 0.32 meters per second. You'll notice there aren't a ton of questions on this Science 10 exam that you'll need a calculator for. This just happens to be one of them. There's usually a handful, so make sure you do bring your calculator. It will definitely come in handy. Just one of those things you should always have. 55. Dan turns his battery-powered toy car, Lightning McQueen. Oh, awesome. This obviously is just asking about a best fit line. And remember, a best fit line is going to go through as many points as possible. Doesn't necessarily need to go through the origin. You don't have to go through that. You want to kind of hit as many as you can. So this isn't a line. This is a series of line segments. So we're always going to get rid of that one right off the bat. You'll notice this has 1, 2, 3, 4, 5 points below the line. Those are all below the line. And this one has, those points are all above the line. This one is a good mix of points below the line and points above the line. So it's kind of like an average, which is the definition of a line of best fit. 56. In the home stretch here. Hockey puck slides across the ice. So we're going to use distance is velocity times time off the back of our formula sheet. 22 times 2.2 times 1.5 gives us 3.3 meters. Honeybee flies 15 meters north in 3 seconds. What's the average velocity? Average velocity is change in position over time. And in this case, 5:58. Spider can crawl 0.52. How long would it take the spider? So time is distance divided by velocity. And we end up with that. Avery, it takes me about an hour to go through it usually. Well, maybe less than an hour. Bus traveling 140. Of course, I've already done this and I have the answers all sitting next to me, so that always helps too. I can imagine you would go through the exam pretty quickly if you had all the answers sitting in front of you as well. One thing to be careful with on this one is making sure your units are matching. So you have kilometers, you have hours, kilometers, hours. You're going to end up with a velocity in kilometers per hour. So 63.3 is 59 D. 60. Does the slope of a velocity time graph represent? Just a simple definition. Acceleration. That's important to remember. And then again, it's super important that you look at the axes on your graphs. This is a velocity time graph now. So we're talking about different graph. Which position time graph represents the same motion? So you notice that as time goes on, my velocity is unchanged. My velocity is very constant. It's not changing. It's 2 meters per second, 2 meters per second, 2 meters per second. When you get to a position time graph to represent that, if I looked at something like this, my position is unchanging now. I'm at 2 meters. So that's not going to work because I'm not moving. We just said that this was something like 2 meters per second. I'm above the x-axis, so my velocity is positive. So I'm thinking it's going to be A. This one is a negative velocity. So this is positive, this is negative, and this is not moving again, so we can get rid of that. So definitely A. Remember the slope of a position time graph is velocity. I have a constant slope and a constant velocity. Okay, thank you, Ava. And I'll bring up the questions as they come up, Abby, just in case you can't get back into Blackboard. All right, the little ant. I don't know why they love this ant so much, but I've seen them on a few exams. Maybe they paid money to license them or something, and they just want to include them as much as they can. Flick. This is acceleration at 4 seconds. So I find 4. The acceleration is going to be the slope at that point. So it turns out that the slope is 1 meter per second squared, east. Number 63, which of the following describes Flick's motion? All right, so slow velocity started at 1, then 2, so speeding up until he gets to 7, and then he starts slowing down. Still moving in a forward direction though, going slower, 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 still positive, until he gets here at 11 seconds and now he's stopped. So at no point did he move backwards, even though that's a negative slope, he's still moving forwards, he's just slowing down. If I were to go below this x-axis, now Flick is moving backwards. So if you read through, you see he accelerated east, then slowed down to a stop. That's probably the best choice, letter B. We know nothing about returning to the anthill. We don't know anything about position, so that's no good. He had a constant velocity. Nope, he was definitely increasing his velocity. He ran a constant velocity. Nope, he was increasing his velocity. So there you go. 64. Car has a negative acceleration. We're looking at acceleration is going to be change in velocity divided by time. So we need a combination of these things. If I go final velocity minus initial velocity, time is always going to be positive, so we need to end up with a negative number on the top or the numerator. And the combo that gives us a negative on the top is car B. So if I'm going negative 2 minus 2, I end up with negative 4. All of the rest will give me a positive on the top. Galileo, trying to figure out the time it took for this thing to hit the ground. Change velocity divided by acceleration. The key here is the acceleration is negative 9.8 meters per second squared. Any object in free fall is going to have an acceleration of negative 9.8. It is given. Most of the times it won't be. If it's going down at 9.8, hits the ground, make sure you're negative, everything will work out there. Driver pulls over and stops to refuel. What is the acceleration of the race car? Acceleration is change velocity divided by time. Plug my numbers in, and I end up with 6 meters per second squared. Superman. Starting from rest, accelerates at 5, accelerates to 5. That could be a bit confusing how that's worded. It says it accelerates to 5, but this 5, this is a velocity. The units are meters per second. So that could be really tricky if you're kind of rushing through a test and you saw Superman accelerates to 5, and then you thought, well, that's probably the acceleration. It's actually not the acceleration, that's the velocity. And then this is one of these ones where we end up with these units. So it's talking about a time of 2 minutes, which is 120 seconds. So don't get caught up there. Different units, right? Velocities in meters per second, your time needs to be in seconds as well. Let's maybe do this one because it's one of these two-step ones. I'm just kind of... acceleration, not change in velocity, divided by time. Starting from rest to 5 meters per second. So my final velocity is 5 meters per second. My initial velocity was 0 meters per second. That took 0.71 seconds. So my acceleration is going to be 7 meters per second squared. 5 divided by 0.71 is 7. So that's how fast Superman is accelerating at. Then it asks an additional question: how fast will he be moving after 2 minutes if he continues to accelerate at the same rate? So we found the rate at which he accelerated, which was 7. Now it's asking, okay, he's going to keep going that acceleration. How fast will he be going after 2 minutes? So we can go with change in velocity is equal to acceleration times time off our formula sheet. Acceleration is 7. I'll include units here. And the time is 120 seconds. So the change in velocity is going to be 845 meters per second. If he started at rest, that's going to be his final velocity. So, tricky question, one of these kind of two-step type ones. They are hard, but you can do them. So they're all pretty much the same. All right, the home stretch here. Earth and space science. we did earth science before March break, but it just kind of falls at the end here. So breaking the ocean floor, which molten mantle material rises, causes A, gives you a bunch of choices. Just looking at, apparently I just quit when I was making my answer key, so I'm gonna have to do this one off the top of my head. I'm gonna need your help. Molten mantle material rises, allows the formation of a ridge, spreading ridge. Remember, if we have our crust and we get that kind of magma pushing up through the middle, that gives us a mid-oceanic ridge. Spreading ridge. Answer question 69. S waves cannot travel through which layer? Letter D, it's liquid. We already went through that one. The crust is part of the core, mantle, lithosphere, asthenosphere. Again, the just basic definition, the lithosphere floats on the asthenosphere. Abby, I can go back, or I'll upload this eventually, and you can have a look at the answers. So we'll make sure you get them one way or the other. All right, 71. Use the following location map to answer 71. What direction of plate movement at X? So you don't have to just memorize this. You can go to your data booklet and look it up. I don't know why I quit on my answer key. Maybe I ran out of time or something. So if I go to my data booklet, which you guys should have with you, find the plate tectonics section with the map of the world. At that particular point, it shows we have subduction happening. So that means we have a convergent plate boundary. And the only one that really works for that is this. On the data booklet, you have all these little triangles. It's not a very good triangle. You have all the triangles on the fault line here. And those triangles indicate that we have a convergent plate boundary. So that means we have plates coming together, and that's B. '72 we did, which of the following tectonic mapping symbols would correctly show this again? We have subduction zone, convergent plate boundary, and that's B. 73, which of the following can deep focus earthquakes occur? We talked about this before. If it's a deep earthquake, you're going to have subduction happening. A transform fault is just sliding past one another. You get very shallow earthquakes. And if you have spreading ridges or things like that, or divergent plate boundaries, you won't have earthquakes that are deep. Which of the following types of plate interactions most closely associated with the formations of mountains without volcanic activity? So we end up without volcanoes. That means we have usually continents converging. And that happens with the Himalayas. Again, if I look at my data booklet, I look for a convergent boundary where mountains are and there's no volcanoes. So remember, on the data booklet, there are little, I only uploaded one page here. There are little, here's a sideways version of it. What if I can rotate one page? You guys can just turn your heads, I guess. If I look really carefully, I see volcano, 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 volcano. And right here, I have a bunch of mountains, which is what the question is asking about, but no volcanoes. Everywhere else, I end up with all these little volcanoes. So continental-continental convergence is what's actually happening at that spot. You have the Eurasian plate running into the Indo-Australian plate, and that's two continents. India running into that plate, causing mountains. Use the following graph that illustrates temperatures within the Earth to answer question 75. Which of the following factors contributes to the highest temperature within the earth? Never seen this question before. So it looks like we have magma forming, and then we have iron melting, and then the iron solidifies. So the deeper we go, we end up with kind of liquid in this, and then we get a solid iron after that. We have temperature increasing going across this way as depth increases. So the deeper we go, it looks like the hotter things are getting to a certain point. Which of the following factors contributes to the high temperatures within the earth? High temperatures within the earth. Slab pull only happens at the surface. So I'm going to get rid of that automatically. And then any answers that have that in it. Okay. Heat within the core is looking pretty plausible. And then this is talking about radioactivity in the mantle, which doesn't really have anything to do with the rest of the graph. I mean, we're going to have mantle kind of in this section up here. So I'm just going to go with 2 heat within the core. Does anybody disagree with me on that one? You like D, Abby. 2 and 3. Which of the following factors contributes to the high temperature within the earth? I guess it could be radioactivity within the mantle. I mean, you're in the mantle in this kind of section here. Radioactivity or heat within the core. Sure. Radioactivity is why everything's hot in there, so that makes sense. I don't know about heat within the core now. I'm thinking about it more. I guess it could be either A or D. So doesn't the magma within the mantle remain molten due to heat from radioactive elements? Yes, it does. So maybe it's not heat within the core if we're just thinking about it that way. Maybe it's just the radioactivity. I don't know. I'm kind of on the fence between. I think the graph is kind of throwing me off because it's telling us that things are getting hotter. I've changed my mind. I'm liking B, just B. I don't like 2 because, well, no, I've changed my mind again. It's D. I'm going D. So we do have pressure, which the heat radiates outwards. The radioactivity in the mantle keeps everything hot there and moving. So I'm going to go with D. Final answer. I like that. I like D. Go with D. Thanks for convincing me on that one. 75, 76. Which of the following factors are responsible for the continued motion of the Explorer plate off the coast of BC? Again, you guys don't have to have this sort of memorized. We can go to our data booklet, go off the coast of BC, find the Explorer plate. See that we have a divergent plate boundary here, which is kind of causing this little tiny plate to get pushed under the big North American plate here. So, sorry. Slab pull ridge push. We can go with that. Which of the following discoveries was used to support continental drift theory? Fossils of identical species were found on the same continent. That doesn't really help us at all. Fossils of identical species were found on separate continents. That's looking good. Fossils of different species were found on the same continent. That doesn't really help us at all. Fossils of different species were found on separate continents. It's not really very telling. So B. Haley, it's actually next week at 1 o'clock, not today. So a week from today. 78. Which of the following process is not illustrated in the diagram? So I can see that I have magma causing divergence here. I have a subduction zone. I have volcanic activity because of the magma rising up. So I have mountains, volcanic mountains being formed. I have subduction, so mountain, that's good. Subduction, yep. Yep, no hotspot. A hotspot would just be if this were the same diagram and there was like a hole in the middle of the plate with magma coming out of it, then perhaps that would be indicating a hotspot, but there's no single spot on this diagram. Which locations provided evidence that led to current widespread acceptance of plate tectonic theory? Gotta give me such tough questions in the earth science section. They didn't understand hotspots, so anything with 1 in it's going to be gone. 2 and 3. This is mid-oceanic ridge and subduction zones. Or 3 and 4. Subduction zone and volcanic island arc or volcanic activity. When they came up with plate tectonic theory, trying to separate my continental drift theory with my plate tectonic theory, at that point they knew about the mid-oceanic ridges. So that's C, because the divergent sort of plate boundary was why the plate was moving. It was pushing, because the magma rising up, pushing it along. So the only one that has this guy in it is letter C. Last question. A trench occurs at a convergent plate boundary. I drew this amazing picture last day, so I'll just leave it at that. And that's the exam. So there we go. Is there anything that anybody had questions about in that last kind of half of that test? I can go through that. Abby, you had some questions that you wanted to go through. I will discuss that. I really don't have anything much more to say. I wanted to go through at least one exam with you. I can go through an additional exam next day. We only have, I guess we have a longer class. It's kind of up to you guys what you want to have happen here at the end. Obviously, you guys have this provincial exam. Social studies is kind of done now, which is nice. You can focus on science. So if you guys want something specific, I'd be happy to do that now. If you guys want to sign out and go study or work on some of the stuff from the course, that'd be fine as well. Just kind of wrap it up while you guys ask any questions you might have. Remember, everything's due on Friday, so all of the learning guides, all the tests, all the reviews, all the assignments should be done, all of them anyways. Some of you are, some of you are not. And then following Monday, so after the weekend, the Monday, one of these is due. I don't care which one you pick. This year-end review is just a bunch of notes and things like that. Practice exam 1 or 2, or you can do the one that's kind of built into the course. So you can pick a test, or you can do the big long review, and then chemistry is optional, but it is there. Submit it here. So this is due Monday. Everything else is due on Friday. So give you guys the additional weekend to get this in. That's kind of where we're at. So if nobody has any questions, I know Abby, you had a few, and you wanted to look at all the answers, Abby, because you missed a few trying to get in and out of Blackboard. So do we do A and B? For the third part, Taylor? Yes, you do. The multiple choice is, I think there's 47 questions multiple choice, and then the rest of the marks come from the written. So it's a total of 80 marks, like the practice exams are old provincials, so that's 80 marks, 80 marks. This is 80 marks as well. And then I'll make the year-end review out of 80 marks. And yes, so do both A and B. Little mix. Any other questions? I see you typing, Avery, so I'll give you a second. I will stick around and answer any questions you have. If you don't have any questions, you're free to go. Yes, Avery, for sure. If you do 2 exams, or if you do whatever you choose to do, I'll definitely pick the better of the 2 marks. And I mean, you can download the exams. I'll put the answers up on Tuesday I guess it has to be next week. So everything's due on Monday. I'll put the answers up on Tuesday so you can go through the exams on your own time after the fact as well. So there you go. Abby had some questions I'm going to go through. If you don't want to see any more science today, you're free to go. If you have questions specific to anything, I'll stick around as long as you guys need. But I don't imagine you have a ton of questions yet. As we get closer to the exam, you kind of realize you have more questions. Can we hand in the one we did today? Well, I've gone through all the answers, so I mean, there's nothing to stop you from just writing all the answers down. So no, do one of the other ones, and it'd be good to get exposure to more exams, Taylor. It'll just, it'll help you in the long run. So do one of the other ones. You have lots of time. You have the rest of this week. You have the weekend. Lots of time to do an exam. Remember, these exams are only supposed to take 2 hours. So, I mean, it's 2 hours of your week where you sit down and do an exam. Shouldn't take terribly long time. All right, I think a few people have signed out. If we have a question from one of the practice choices you're allowed to look at, for sure. I don't have any issues with that. I mean, if you don't understand, there are definitely some tricky questions on the exam, so I can't guarantee I'll know it off the top of my head. I might have to look something up, but I can definitely go through anything like that. Abby, you had some questions at the beginning. Could you talk about what are the most important concepts for biology and earth science, just in general? Haley, yes, I can definitely do that. So, it's hard to pinpoint one topic in biology. Obviously, the biology stuff is kind of a big section. There's 3 chapters on biology. Just kind of scrolling back to the biology section of the exam. I mean, if I were to study the biology, I would look at a lot of the vocab terms from that section, the first 3 chapters or units, because biology is like really heavily entrenched in vocab. One thing that I wouldn't spend time on was looking at the cycles, so phosphorus, nitrogen, carbon, because they're in your data booklet. So don't waste your time trying to memorize things that are in there. Make sure you're using your data booklet as much as you can. Things to memorize, things to understand. It's hard to put like a pinpoint a few topics that are important. They're all equally sort of covered. Nothing is any more important than anything else. You're going to see a chromatograph question. You're going to have a bunch of biomes questions, but you have the biomes in your data booklet, so maybe it's not worth spending a ton of time there. I mean, you have like bioaccumulation, bioremediation, just the vocab in general. POPs, succession, predator-prey cycles, everything's kind of going to be equally tested. 22 questions on this one on biology. If I were to study for biology, I would ignore biomes. I would ignore all of my nutrient cycles because that's all in the data booklet. So I wouldn't waste my time looking at stuff that wasn't there. Things like natural selection, that sort of concept. I mean, realistically, you're going to see one question on all of those topics, and It's just there's nothing specific that I can say, look at this, because it's all equally tested. So I couldn't be more help with that. Same thing with earth science. Earth science has a lot of plate interaction sort of stuff and layers of the earth. So that's kind of the big two topics there. If you can do the plate interaction stuff and layers of the earth, you'll be all right. The important thing with the plate interaction is to refer to your learning guide as well, because it's all there. And I wish I could tell you something specific, Abby, but there isn't really anything specific for you to look at, because it's all kind of equally tested. Haley, I can do that for sure. Converting meters per second. And number 12 on page 4, unit 8 learning guide. Yes, yes, and yes. Let's convert something to meters per second from kilometers per hour. Is that what you asked specifically? Sure. Let's pick a nice number like, I'm going to cheat right now. No, I'm not. Let's pick 100 kilometers per hour. Just because I like the number 100. All right, so 100 kilometers per hour. You're always going to have two conversions. One to convert your distance and one to convert your time. Doesn't matter which one comes first. Any one can come first. I see I have kilometers on the top. I want to get rid of it. I'll put it on the bottom. Now, the relationship between kilometers and what I want to end up with is meters. So if I want to end up with meters, I'm going to put it on the top. 1 kilometer is 1,000 meters. That is just one of those things you have to know. The second part of my conversion here is hours. I have hours on the bottom. If I want to get rid of it, I'll put it on the top because they're going to cancel. And I want to end up with seconds on the bottom. So I'm going to have to put seconds on the bottom. This is one of these other numbers that you should just memorize. 1 hour is 3,600 seconds. How does this work out? Well, or does it work out? I have kilometers on top, the bottom, they cancel. And I'm left with seconds, which is what I wanted. I have hours on the top, hours on the bottom. Those are going to cancel. And I'm going to be left with meters. So I'm going to go 100 times 1,000 divided by 3,600. Bring out my calculator. 100 divided by 3,600 times 1,000. It's 27.7 or 27.8 meters per second. So you're always going to have the two steps. One to get your meters and one to get your seconds. If you're trying to get rid of something like kilometers, you put it on the bottom, top and bottom cancel. That's kind of the key there. Page 4 of the Unit 8 Learning Guide. Sorry, just number 12. What is the skateboarder's displacement velocity between 2 and 5 seconds? So the displacement is the change in position. That's displacement. Sometimes it'll be written like that. And you're going to have the final position minus the initial position. So everything that happens at 5 seconds we'll call final. Everything that happened at 2 seconds we'll call initial. So the final position was 7 meters. The initial position was 2 meters. So how far did that person go? Well, they went 5 meters, and then it's a vector, so we include